This stuff that we're seeing right here, this is all kind of review stuff, but it relates to the inequalities because I believe they do want some intervals on these. We'll see. Since even roots cannot have negative radicands, this doesn't have to make perfect sense to you guys, but for roots of expressions, the domain is all numbers that make the radicand greater than or equal to 0. So let's go to something that hopefully is slightly familiar. If I said the square root of 4, that's asking what value times itself is 4. It's 2, right? Now, if I were to make that a negative 4, so I've changed the problem, right? So let's get rid of the 2. What value times itself is negative 4? It's just, right now, the only thing we need to remember for now is that it's not real. We will have a unit on how to do these problems. Unfortunately, there are such things as real numbers, which you're very familiar with in life. But math people, once they felt like they had mastered real numbers, they felt the need to go and find not real numbers. And now we get to go over that in Math 1010, which you get, yeah. So I can feel the excitement though. In any case, the radicand's the inside of the radical, that's the square root. So negative 4 would be considered the radicand. Just inside, we can't make it, it cannot ever be negative. So if I were to change this a little bit, and let's just say that it's x, okay? So x, could x ever be negative? No. Could it be 0? Yeah, sure it could. So you could say for your domain, and I'm not doing this like I probably should. What the crap. Set builder notation, okay? So I would say that x, right here, I could make it equal to 0, but I really need it to be something bigger than 0 as well. But 0 would work too. So this right here that I've shown is set builder notation, but I think I got a slide on it. Let's get to the math language, because no, it's neither. It is neither. So this is set builder notation, and math is its own set of hieroglyphics, which is why, you know, we're misinterpreting this with symbols that we're familiar with, right? Absolute values, like you say, or a 1. It's neither. This reads, not that I think you care, this is set builder notation. So how do we know? Because it's got the fancy brackets, and they're super fancy. I did a pretty good job, and I feel good about it. But in any case, this reads x such that x is greater than or equal to 0. Boom. So that's how it reads. Again, I don't think you care. Just this first part, sometimes people are like, isn't that redundancy because you have x and then you got an x? Sure, I didn't make this up. Someone else did. Some math nerd a long time ago did. And welcome to math class. Here we go. Domain in interval notation, right? So here's what I know is that I've got to take the inside of that square root, which is called the radicand, 5x plus 8. And I need that full value, that full radicand. I just need it to be bigger than or equal to 0. And that will be my domain. But of course, we need to solve this. That will help us to put that in interval notation. So 2 principles of equality should do. Subtract 8 from both sides. That zeroes that out. Drop your negative 5x, which is greater than or equal to negative 8. Again, we subtract it, so that won't affect the inequality. But this next one will, because I'm now dividing both sides by negative 5 to make that a coefficient of phantom 1. So that's going to flip the inequality because I divided both sides by negative. I now have 8/5. So x, as long as it could be equal to 8/5, but if it were less than 8/5, that would work too. So at this point, usually if I have an inequality, usually if I'm going to make interval notation, I like to see the visual representation of this. So I like to make the graph, although most students don't, and that's fine. So right in the middle, I'd have 8/5. I can do a better 8 than that most of the time. To the left would be 0, and then to the right, I don't know, 2. Thank you. So at 8/5, I'd have a closed circle because it could equal to 8/5, but this one is not eating the x, so the line goes to the left. So my interval, it goes all the way to negative infinity. It stops at 8/5, which is included, so I need a square bracket. And this part right here, again, I was using the graph to see as far to the left as it goes, stopping at 8/5, but that's my interval right there. yeah, for these, just since we're looking at the domain, yeah, do completely ignore that square root. Thank you.